We've come a long, long way together through the hard times and the good. I have to celebrate you, baby. I have to praise you like I should.
So there was this DJ who was like kicking off. I don't know what he was doing, but it was sick, man. Like he was like hands in the air, like penis out. And then this cat walked in, you know, not like a cat, like a feline cat, like a real, like you know what I'm saying, dog, like cats and dogs. It was raining. It wasn't raining, we were raving. And I don't know whether he was really saying it. And all he kept saying was eat, sleep, rave, repeat, eat, sleep, rave, repeat, eat, sleep, rave, repeat, eat, sleep, rave, repeat.
Eat, sleep, rave, repeat. Eat, sleep, rave, repeat. Eat, sleep, rave, repeat. Eat, sleep, rave, repeat.
Eat, sleep, rave, repeat, eat, sleep, rave, repeat, eat, sleep, rave, repeat, eat, sleep, rave, repeat.
Eat, sleep, rave, repeat. Eat, sleep, rave, repeat. Eat, sleep, rave, repeat.
Hello, sorry for the slow start. Alright, we're going to be doing some neural network programming. I'm going to be continuing where I left off last stream. So, last stream, I was getting AVX intrinsics working. So I got that. So the neural network is optimized with Vector 8 instructions. So then what I'm going to do next is I'm going to continue what I was doing before and test the different evolution methods, see which ones are fastest. I'm going to create a different test with the recurrent neural network so I can see if it's faster with that as well. So this was just me setting the weights and biases to test the AVX instruction. So I'm going to turn that off now. And I believe, yeah, so I have AVX turned off. So I think what I'm going to test next actually is the training. I'm going to test training the neural network, the backward, the output layer, see how much that speeds it up. Let me just see, how is this calculating AVX? If it uses AVX. So if any of the layers are smaller than, okay, yeah, alright. So, and comment all of this. Alright, so I'm just going to turn the music up, and I'm mostly going to focus on this. There's Fatboy Slim.
Fatboy Slim is fucking in heaven.
Yeah, you hear it there. So I'm just thinking, how do I want to add training here? Why was this one 9117? Did this have a different desired loss? Or a different number of iterations? A different number of iterations. I'm just gonna run this again just to test. Supposed to be G count. Oh, actually, never mind. This is supposed to be commented out. Let's test. There we go. Okay. So this should take a bit to execute. Not that long. Alright, so that is right, 9117. So what did I do to optimize that? I need something to speed that up.
If you came to party, let me see your hands up.
So what am I doing here? Lurking between these.
Hands up, everybody now, let me see your hands up. Everybody now, let me see your hands up. Everybody now, let me see your hands up. Right now, hands up, everybody now,
Okay,
let me see
I
your
see
hands
what's
up.
happening.
Everybody now, let me see your hands up.
What's this set to?
Let me see your hands up. Right now, hands up. Everybody now, let me see your hands up.
I guess that's working really well. Alright, I'm gonna try adding training now.
Hands up. Everybody now, let me see your hands up. Everybody now, let me see your hands up. Everybody now, let me see your hands up. Right now, 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 right now.
So I'll do the brute force.
Time to get off of the ground.
Alright. So to do the training, I need to set the derivative right here. And the training rate. I'm going to do a training rate of 0.3, I think, or maybe 0.2. We'll try different values. I'll try 1 actually to begin. And then we can do neural network stream. Like that. Alright, that should work. Alright, now we'll see how much that improves the brute force evolution. Oh, it seems to be improving it massively. The brute force evolution was taking a super long time before. Alright.
what the fuck? Everybody on drugs.
Oh my god, that sped it up giant. Let's copy that. Alright, so that's from 1.8 million. I think I copied the wrong thing. So 1.8 million to 95k. That's huge. Now let's try it with the LERP genetics and training. Oh my god, that's so fast. Alright, so training gives it like a, let me calculate the magnitude of increase. So for brute force, so it's 5%. Brute force gives 5% of the processing time or speed, a 19 times increase in speed. This one is a lot less. So the LERP genetics got a 4 times % increase in training. That's still awesome. Okay, so I'm going to create a test for a recurrent neural network now, which should test this way more. And there's another kind of evolution I want to try using Voronoi sampling. It's a bit more expensive and memory intensive, but I think with a big population and complex neural network, like a recurrent neural network, it'll work way better. So I'm going to rename this. Different tests. So now I'm going to turn this main code into a recurrent neural network. So first of all, I want text. Is Shakespeare public domain? What's the public domain? Text files. So let's see if I can get some text files of Shakespeare plays. And then I can run this into the neural network. Maybe I should do poetry. I think that would be cool. So I'm going to create a text file called text. And the neural network is going to train to try and output the text. Or guess what comes next. Which is basically learning to output text. Basically learns to generate the probability of which one comes next. Goes from there. Call it text.text, I guess. I don't know how many of these I'm going to copy. I think this will almost be enough. The more text though, the better I think it'll be. The more the neural network will have to generalize from. The other question is, what kind of recurrent network am I going to build here? Alright, I think that's enough. It's a good amount of text. If I want to get more, I'll keep this web page open. So I'm going to use one-hot encoding. Hey MRes. I'm doing pretty good. So the first thing I'm going to need to do is actually load in my text and run it through one-hot encoding. Actually, I just need to load in the text and then I can do one-hot encoding as it feeds into the network. I'm just going to load in the whole text file. I've got this function file read all that reads all the text. Gotta make sure to do proper errors. Okay. Man, I don't know what kind of structure I want for this. I guess I'll just start with one hidden layer. And I don't think I'm going to do a recurrent network again. I think I'm just going to feed in the old state and let it work from that, and then see if it can work better with a memory of its own. We'll try both. I'm going to try both outputting and doing the recurrent network model of where you output the hidden or feed the hidden back in as input. Alright, so I guess I should structure the network. Is that music comes from and stops? I can turn the music down. Music is pretty loud. So for this neural network, it's going to be really hard to even get a target loss. So I think I might do a different kind of, oh man. So that's the really hard thing. I'm going to need to test this and actually see what kind of loss is actually achievable for this text neural network. Anyways, let's build the network. Should I just assume all the characters are here? Yeah, so the hardest part of the text neural network is the text encoding. Thanks for the follow, MRes. So I'm not going to do uppercase letters. I'm just going to do lowercase. I don't think I'm going to do commas or exclamation marks. I'm just going to do spaces, I think. So I'll probably need to convert text to that or something like that. Should also calculate what characters are used, maybe. I'm just going to assume all the letters are used. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. Yeah, all the letters are used. Okay. Alright. So that's good. Yeah, the hard part though, how to encode this text. I guess what I'll do is I'm going to open up trusty old ASCII table. Yeah, so we don't want any of those. So we want space, and then from here to here. So first of all, what I'm going to do, I'm going to read through the text and I'm going to convert it to lowercase. C just has a function called toLower that converts characters to lowercase. Alright, and then our number of characters is going to be our number of input neurons. Or it's going to be based on that. Alright, so I'm going to do the encoding, one hot ID. This is going to convert a character to its one hot neuron ID. So if it's smaller, 97, or bigger than 122, then just return space, which is going to be 0. Why don't you just write int 0? It's just, I get in the habit of writing uint32. That way you know it's a 32-bit integer. Which, if you're obsessive like me, is important. It's not really important, but... So then just subtract by 97 so that it becomes actually 96. So then it becomes starting from here. So 0 right here will be space, and then you'll have all the letters. So then at the beginning, I'm just going to output. So there's going to be 28 one-hot characters. Actually, wait. No, wait. I'm an idiot. 27? 122 minus 97. Okay, yeah. Like your style, by the way. Thank you. Okay, so 27 input, 27 output. I'm gonna do like 10 hidden neurons. Oh my god, wait. Oh, this is... I should have tested with more different populations. So the genetic algorithm, the higher population count you have, the faster it is. I only tested this with a population size of 3, which is really small. So I'll actually have to go back and test that with higher population size. So I'm going to disable the training right here, just for these tests to begin. I'm going to see how it works with just evolution. Okay. So I'm going to set the target loss impossibly small so this never finishes, just so that I can test it. Then every time... Oh wait, this has no measurement of the best because it goes through... Oh, I have to use this to test the best. So I'm going to output every time the loss gets better. So that way I know what the actual range it can train to is. Oh man, I started programming this like 2 weeks ago, maybe a week ago. I stopped programming it for like a week, and now I'm even having to remember what my code is. Neural network. What? I mean, what's its purpose? It's a general purpose, fully connected neural network. Just uses rectifier linear activation functions. Are you training it with general adversarial? No, I'm just training it with evolution, genetic algorithm. That's one of the things I'm doing right now, is I'm testing different ways of doing it. Oh yeah, training with genetic. Wait, by GA do you mean genetic algorithm, or GA do you mean generative adversarial? Okay, yeah, genetic algorithm. I'm training with a mix of genetic algorithm and training the output layer, but I'm not doing any back propagation to train the hidden layers.
This hit that ice cold, Michelle fight for that white gold. This one for them hood girls, them good girls, straight
GA. Yeah, I don't know. I don't hear a lot of people talk about genetic algorithms a lot. I see a lot more about generative adversarial networks. That was the first thing that came to my head. So right now I gotta see if the loss is gonna be better than the best current loss. I'm gonna output that to the console so I know what the best is. There we go. Alright, so now I'm gonna need to do this training completely differently. It's gonna be a lot harder. So I'm just gonna do brute force evolution to begin. No genetic algorithm. So this is the old code for training a triangle wave. I'm gonna need to train the. So now first thing I'm gonna need to do is I'm gonna input the text. Then work on the exact same topic. Did one project with a population, another project with a hill climber. Nice. Yeah, shake that ass, Sepu. Show me those genetics. So I'm just going to need to loop through all of the text. Oh, wait, I'm already using I. So I need to use K. So what I'm going to need to do is I'm going to need to input to the network the last character, and then the network's going to output the probability of what the next character should be. I don't know how I'm gonna do this. I think I should maybe do it fixed. So what I do is, dude, I love Fatboy Slim and his remixes. Said, who have you seen my work? I haven't seen it for a few days. I think you've been making good progress with that path tracer though. I'm guessing you have some new pictures now. So the hard part of this is figuring out how I'm going to input and output the neural network state efficiently, because I could just set it. Alright, so first things first, I should get the one hot ID. So last one hot, or last ID. Did post some pictures. If they're on Discord, I'll look at them afterwards. Alright, so from the text. If only this program had a nice interface. Oh god. So yeah, I'm gonna be setting these manually. I don't know if, oh, man, I guess I should reset them after each. You know what, actually I can reset them manually after this. So what one hot encoding is you have a neuron for each character. So like a neuron for A, a neuron for B. So if there's A, you have 1, you input the value 1 to the A neuron. And then of course there's nothing, you input 0 to the B neuron, C neuron, everything. So then if there's a C, for example, you input 1 to the C neuron, 0 to everything else. So to do this efficiently, I just need to set one of these neurons to 1 and set the old neuron to 0. Hold on, I need to get some water. All right. Okay, so set the, so this is the, oh. Okay, that's not it, but, so n layers minus 1 is the output layer. So I need to set the, I don't need to set the output, I need to set the input to the last ID.
Now you're going to die.
So the input is 0. So I guess set that to 1. I think that's actually it. Then I just run the network. Now, to get the output, whatever it outputs, so I'm actually going to need to calculate the derivative here. Instead of doing a single derivative value, actually I'm going to need to calculate a whole set of derivatives. So I'm going to need to loop through here, loop through the output neurons. And what I'm going to need to do is set the one that is the ID to... Oh, actually, so the most efficient way to do this isn't to do an if statement in there. It's just to set all of them to... Oh, damn, actually, I do need to do the if statement. So if the neuron is the correct one that's supposed to output. Oh wait, I should also get a pointer to this. So this would be state pointer. So now we need the output. So this gets a pointer to the array of output neuron states. So now we want to convert these into the derivatives that we're going to use to train the network. And also use to compare how well the network is doing. So actually right now I don't need to calculate the derivatives, I just need to calculate the loss, but you know, we'll do both. Alright, so this is going to add up the loss here. Alright, I'm going to set this into a derivative value so that I can add that to the loss easier. So for our neuron here, this is our neuron that we're targeting and we're trying to activate. So we want to make the derivative, set it to go towards 1. So we're going to do 1 minus whatever it output. So then this way, if the neuron's already outputting 1, it doesn't have to go anywhere. Otherwise, we want it to be 0, so we're just going to do negative, because that's the exact same thing as doing 0 minus. Now we set that to the derivative, we add it to the loss, we divide the loss by that to average it, and now we also are going to add the loss to a total loss value, because we're going to add up the average loss over the whole thing. Alright, I think that's good. Actually, it's not. I forgot. I'm supposed to set last ID to this ID, and I'm supposed to set this to 0 after running it. And after doing the training. So, down here, I'll do that. Change it back. So I need to set that state to 0, so the next time it runs, it'll be 0. Okay. Unresolved symbol, file, read all. Forgot to include the right file. Should be stream.h. Yeah, there we go. Okay. Wait, what the? Wait, why is that finishing? That is not supposed to be running. It's supposed to be outputting the loss. Okay, wait, what is it? Loss is... Comment all this out so it just does one loop. I don't want to benchmark this, I just want to... Loss negative 22. Oh my god, I'm an idiot. So here I'm adding the derivative without sending it through absolute value. So it was adding up a bunch of negative values. Here we go. There we go. Okay, loss is 52. That's a lot more like it. That's a lot of loss. Why is it so high? It's because there's no clamp 0, 1 on the neural network. It's max 0 right now. Yeah, max 0. So I found out that actually trained quicker for the triangle wave, so I'm going to do a test here as well where I change it to clamp 0, 1 and see if it trains quicker. But anyways, it seems to be working properly now. Let's run it, we'll see. New best loss, 1. That is wrong. Alright, this is probably going to take a really long time to calculate. If I had to guess. Is everything working properly too? That's the question. Yeah, I think it's good. I think it's just really slow. Let me leave this running. Let me see if it... See, I don't know why it's saying the best loss is 1. If it's smaller than this, it should actually be... Oh my god, it's not. It's not keeping track of the actual best loss. I am stupid.
How y'all feel out there?
Oh yeah. Alright, check this out.
Alright, here we go. I had to write it out.
As it is plain to see, he is DJ Run, and I am DMC, and we are the crush grooving, the body moving, the record making, and the record breaking. And it goes a little something like this.
Here we go. Okay. Wow, that is really bad. Best loss of 9. So yeah, I'm not even going to try brute forcing this. It's taking so ridiculously long. I'm going to try doing the genetics. Oh, got 8.6. I wonder, am I forgetting? Or is it really just... No, I'm dividing C loss by 27. So there's 27 in the neurons, so... I'm dividing loss by text size minus 1, which is right. Alright. Alright. Let's try it with the genetics. Wow, it's not much better. I wonder if I'm feeding in the data wrong. I wonder, maybe the hidden layers are useless when I'm just feeding in. Yeah, interesting. So now it's even better.
Get on the floor if you got that booty.
I wonder if I should output and generate the text. Yeah, so I think the huge thing is that this is such a big thing of text that it's just like not. Oh man, it needs more neurons and it's going to take a long time to train. I'm wondering if I should turn this into a smaller test with a lot less text so that it trains a lot quicker. I think I should probably do that first. So I'm going to keep this text. I'm just going to rename it something else. So let's start with something really simple. Let's just do hello world. I am a neural network trying to generate text. See how it does with brute forcing now. Yeah, I feel like I should output the generated text just so that I can see what's actually happening. That way I'll also know if anything is going wrong. I feel like the text generator is also like, it's better for me to look at the generated text than just a number of how wrong the characters are. So yeah, I think I'm gonna change this. I'm gonna comment this out. And instead I'm going to make a loop that trains it and outputs the text. Well, it doesn't train it, evolves it.
Ain't number tutti frutti. Get on the floor if you got that booty.
Yeah, I shouldn't retype this. I'm just going to reuse this code. It's basically going to do the same thing, except at the end it's going to output text. I just realized as well, character is signed, I think, not unsigned. I don't know if that would mess up this math. Might do uint 8 just to be safe. Alright, so it's going to loop through the text like normal, get the loss. It's going to possibly train it, possibly add it to the genetics. And then when it's the new best, I am going to generate text to show what. Wait, this is basically the exact same thing as this here, except it's generating text. Yeah. Man, I should have just inserted this code right here. Alright. So I'm going to generate a random number of characters, starting with a random character. So basically same thing as here where we've got our last ID, but I'm just going to do this randomly, or I'm going to seed it randomly because I'm trying to generate random text. Actually, you know what? I should output what it generates. What am I doing? I shouldn't generate text. I should output what it's generating for here. I'm just going to repurpose this. I wonder if I should just keep track of it here. I think I will, so then I don't have to run it over again. So I'm going to create a buffer. So then this is going to find the max ID. And then this is going to be the character that the network outputs. So we're going to do text buffer, character, was MID. Or actually this is supposed to be, so we gotta do a backwards, we gotta do from one hot encoding to a character. So if it's 0, then it's just space. Otherwise, it's the ID plus 26. Alright, and then tbuff 0 is always going to be text 0. So it's going to output the text there. Alright, there we go. So let's see what that looks like. Alright, that is very wrong. So basically the only thing it has right is the first character. Oh, that one gets a bunch of E's and hello world. This is what it's supposed to be generating. So this is going to be a good test of how many neurons I also need to do what. Now I'm going to try it with the genetics. Alright, now we're going to try it with 100 hidden neurons. See if it needs hidden neurons. I don't think it is because it's just getting the last characters in. I think it needs memory. It's the main thing. What's interesting here is it actually looks like the genetics are actually doing worse. Yeah, for whatever reason, the genetics are giving way worse losses. That's weird. Huh. Did I change something about the loss? I don't know why the loss was like 2 before. Now it's way higher, but it actually looks like it's doing better. Oh! Guess it's the hidden neurons causing the values to go super high. Oh, okay. Yeah, so the hidden neurons didn't help at all. So I'm going to do multiple values inputting. So that means I need to, I'm going to create a define for how many inputs. Memory. So memory is going to be the number of characters that it remembers from previously. So this is just going to remember 2. So I need to turn this up. But now I'll be able to use this define for all of these values. And I'll actually need to remember multiple last values now. So now I'm going to need to loop through. Set the last values. Oh, wait. This is going to need to be like a stack. Where I like have a last pointer and go through it. Or step through it. Yeah, so I'm going to initialize the state as I go through this. So now I don't need to do any inputs there. I still do the exact same comparison here. Still do the same output. Okay, so the one thing I change here is how I set and remove the last values here. Okay. So first of all, setting the next last value to last pointer equals ID. Last pointer equals last pointer plus 1 modulo memory, so it wraps around. So then the one that's getting removed right here is -1, I think. Okay, wait, so this would be now that I switched this around, I don't know what I'm doing. So when I'm setting this ID, I think I need to remove the old ID. Yeah, so screw actually keeping these last values. I don't need to do that. Instead, I can just loop through here, setting the initial values. So at the end of this, I need to uninitialize them and set it to 0. And that's all. Alright, let's see how that works. ID undeclared identifier. Where is that? 76. Oh, okay. Oh, something's broken. It's outputting 1. It should not be outputting 1. Wait, 1 is all the way over here. How is it outputting 1? What is this character 1 hot doing? This 1 plus 96 should give the correct. Oh, I'm not initializing all of this. So this is with Brute Force Evolution. It's really bad. It hasn't even got each HELL. Let's try with genetics. I think the trick is also to do training. I think training is going to be key for this network. So it definitely should be able to get HEL. What's interesting is it seems like for this, the genetics are actually worse. For whatever reason. I don't know if it's because it's not varied enough. It keeps trying things within the same area. Who knows? Let me try that again. Is there a reason why? No, yeah, it's definitely performing worse. So I think this is supposed to be 1. If I'm understanding right. In the current system at least. Loss mutation curve. Lerping. This should be a max of 1. Yeah, no, yeah, so that was too high, maybe that. got HEL there. So yeah, it's doing way better now, but not really way better. Let me compare this to the brute force, see if that's what was causing it. Is this still Fatboy Slim? Yeah, it is. Oh yeah, so it was helping. That is good. Yeah, still not doing amazing, so what I'm gonna do is I'm gonna train it. So I don't know if I want to do one calculating loss. Maybe I'll do one loop pure calculating loss and then one loop training. So I'm not going to be calculating loss in this loop. I just want the derivative for training. So then I'm going to run neural network train here. Alright, so now we're going to see. It's going to set the derivatives. Then it's going to run it again. So it's going to run it through training it. Then it's going to run it again after training it and actually measure the loss. Let's see. And I'm doing random generation right now, no genetics, just brute force. Okay, it didn't run. I think it crashed. Yep, it crashed. Okay, what made it crash? Was it the training function? Yes, it was the training function. Damn. Let me compare this to the triangle wave. Is there anything? Train? Yes. Yeah, I don't know. Maybe the size of the network is making it crash. There's probably something wrong with my neural network function though. I should probably debug where it's crashing. Just to make sure it's not running AVX. Okay. It's not crashing on the training, I don't think. Yeah, it's finishing training, so it's not crashing here. But something about the training is making it crash, I think. Because if I take the training away, it doesn't crash. So the question is, what is making it crash? Let me check if any of these values are not a number. Is this the right? Oh yeah, I think I have this browser option on again that is actually, oh no. Okay, it is nan. Yeah, so there's no infinite. Alright, so it's probably something to do with the hidden layers, if I had to guess, because it doesn't happen on the triangle wave. Nope, not the hidden layers. Yeah, I don't see any reason why this should crash or cause crashing. I wonder if the width, the weight or bias is becoming not a number. Should still check for not a numbers. I don't think that should cause crashing though, we'll see. Yeah, I don't know why this is crashing. As far as I'm aware, everything is fully functioning here. I want to see where this is crashing. So it's not even crashing in here, it's crashing down here. Huh. There's no way it's reaching the target loss. Oh my god, it was actually reaching the target loss. What the fuck? Okay. Let's see what it's outputting. Huh. Maybe this shouldn't be divided by 27. Just I know it's working now. So I'm going to try not dividing by 27 here. So then now this becomes a question of how many times do I want to train it. Train it 3 times, I think. And then what do I want the derivative scale to be? Okay, something's wrong. It's not supposed to be outputting values like that. Either this character one hot function is wrong, or the ID. Oh my god, this is wrong. It's supposed to be... There we go, that's more like it. Now it's only outputting spaces. What the hell? I wonder if the training is actually messing it up now. Oh yeah, definitely. Alright, so I probably want something for this genetic evolution that takes losses bigger than 1 as well. That's another thing I'll probably want to change. So that's working, it's just the training here that isn't. How small of a value do I need to set derivative 2 to? Oh, there we go. So this just gives it a bit of a push. Oh, nice. That is actually kind of making progress. Yeah, let's see if I can make this take in losses above 1. So maybe for this part, doing a curve. So now let's try it with the genetics. The hell it did hay. So maybe I'll try a bigger population now. With a population of 100, how much RAM is it using now? It's 4 kilobytes, okay. Still not doing good though. Oh my god, since these are probabilities, I should normalize them. Instead of calculating that difference. Oh no. So these should actually be normalized before I compare them. Oh, okay. So I think this neural network is going to be a really good test for the genetics. Alright, so to normalize it, I gotta get the sum. I could divide this by the sum. Alright, so now that that's normalized, that should give me a much better loss. Oh yeah. So I think I can actually just calculate the loss by doing SPID times sum, then 1 point minus. Oh, but then how would I measure the max ID? Oh, but the derivative probably shouldn't be normalized either. I probably want to train this towards 1 and 0. So this is actually just 1 point minus times sum. Oh, there's no SP++ here. Oh no, what did I do? Why is it taking so long now? Oh, that's reading out of bounds. Oops. Oh man, I wonder why it's training to do all these spaces. I guess it's because spaces occur a lot, so it gets a reduced loss. I think I'm ready to try training again. Oh my god, this is training wrong. This is why I'm an idiot. It's training it all to be 0. Oh my god, I'm getting tired. I'd save this for tomorrow. Still training it to do spaces, but I think that's just because it's weird how it's displaying T's here when it should just be displaying nothing. Like, because it's outputting one of the last 2 characters. Oh, actually, I get it. God, the training is actually seeming to make it worse, though. Which makes me wonder. Why is it favoring spaces so much? I feel like I'm doing something wrong. Good night. Now let's try increasing the population. Now we'll try a bit of training as well. I gotta watch out for exploding derivatives, I think, as well. I think the normalization might be good here. Let's try the normalization here.
Something that is right in front of you, and I just want them to notice you.
Oh, there we go. That's working really well. Henry Toret Nia, yeah. It's crazy how it Heltor RR Gnet Hexengoro Agetanet Nat Ratat Gone.
Smoke is flying everywhere. I'm getting the feeling it's the end for you and me. And
I might even need to increase the memory more.
I know that we might be through, but I'll never let go of you. I'll never let go.
It almost got working right there. Wow, it's actually getting close. It's slow, but Oh my god. It's really close. Hello, Gork, Netrat, Network, Tang, Genitate, Text. Whoa, okay, it's working. So I think that's the best it's gonna get, with only 2 characters. I might need to turn it up to 3, I think. I'll turn the memory up to 3. So let me see if I can get this better with less training. Amazing. Alright, so training it is the key. Alright, so more is better. Let's see how slow it is with the randomized option. Let's see if it's any faster. Still working pretty damn well. So let's try with a memory of 3 now. Oh yeah, it's basically got it. Hello work, item, natural network, Tang to generate text. Very close. I wonder why it's doing work instead of world. I see. This is the way the memory's working. So I should look at doing this as a recurrent model actually. Feeding in the last state doesn't really work. It doesn't work amazingly. Is that the best it can do? Hello worked, I am natural network Tang to generate text. Yeah, I guess that's the best. And it does it, finds it pretty quickly. I think the random version here actually finds it better than the genetics. Yeah, so I'll need to find a better example that this trains really quickly. That's probably going to be the end of the stream tonight. I had some pretty good progress learning this. I'm pretty happy with what I learned, and I think next time I do this tomorrow, I'll be able to get it working well enough and be able to finish the testing. So thanks to anyone who watched. I hope you enjoyed the stream. Follow and check back again for more neural network programming. Have a good night, everyone.